You know that all of you have had Calc 2, but based upon past experience, there's a variety of trig comfort, so let's do one that's going to involve trig. And we'll stick with our 5 microcoulomb just to save us a little bit of time to work. 8 centimeters between them. And we'll stick another one here, 3 microcoulomb, and let's make that 6 centimeters. And what I want to know is what is the force on the 3? Well, it clearly is going to be the sum of the other 2 forces. I hope that's clear. So it's the force on 3 from the 5 plus the force on the 3 from the 4. Okay. Actually, using 5 and -4 doesn't do anything because we're not calculating that force. First off, let's just think through the directions. What is the direction of the force on 3 from the 5? All right, seems like it seems to be a groundswell of 3 people who are pointing in this direction. And the direction of the force on 3 from the -4? Okay, let's figure out the magnitude first. So this one right here, so the magnitude of the force on 3 from 5. Absolute value symbols representing magnitude. I'm assuming that was, you're familiar with that. Or did Miss Sosson use the double absolute value?
Just right.
So that,
I think it's just right.
I think it was
Just absolutely.
the singles? Okay. I tend to use the singles, also some textbooks will use the doubles. All right, so I got the magnitude of force on 3 from 5, and it's going to be my Coulomb's constant times the charge, so I got 3 times 10 to the -6, times 5 times 10 to the -6, divided by that distance. What is that distance?
Meters.
Pardon?
Points years. No, sorry. I was thinking I was reading 4.
What do you want your distance from 1 to 1?
This is the force between 3 and 5, so that distance right there.
0.14.
Oh, 4, yeah.
Yeah, conveniently it's a 3, 4, 5 triangle. All right, so I have 0.1 squared. Crank through that. 135 times 10 to the 13.5. What is it?
13.5.
13.5 newtons. All right. The magnitude of force on 3 from 4, 9 times 10 to the 9th, times 3 times 10 to the -6th, times 4 times 10 to the -6th, divided by 0.06 squared. Never took my minus sign.
It's absolutely fine.
Yeah. All right, so I now have the magnitudes of these two. I have to sort of break it up into components. It's not expecting to be that much bigger, but I guess it is, I guess. Yeah. All right. Breaking the 35 up, I know it's going up at this angle right here. I need to break it up into horizontal and vertical components. I'm just going to go ahead and establish a convention here. I hat to the right, J hat up, because I'm lacking originality. been brainwashed, the same way you have by the math people. So I have, this is 13.5. Newtons. I need to figure out what the two components are here. I know that physically, the direction of that is also the same as similar to that triangle right there. I know this is going to be 13.5 times the cosine of theta, and 13, what else did I actually put the decimal point here? 13.5 times the sine of theta. The cosine of theta I know is the adjacent or the hypotenuse, so 8/10 or 0.8. So this becomes 13.5 times 0.8 and 13.5 times 0.6. Now, if you want to actually find the angle, go for it. I'm going to introduce some rounding, but does not take away from the essence of what we're doing here. This is,
Isn't it 0.08? Or no? Am I doing like a rounding thing differently?
oh, why that's 0.8?
Yeah, why that's 0.8 and not.
Cosine, adjacent over hypotenuse. So you have 8 centimeters over 10 centimeters.
Yeah, but 8 centimeters is 0.08.
That is true. So I got 0.08 meters over 0.1 meters.
No, that's right.
Oh. Okay.
If you found the angle, that angle right there, theta would be the arctangent of opposite over adjacent 6/8. And you'll find that comes out to be somewhere around 37 degrees. And if you did cosine of 37 degrees, you'd get 0.8. 36.8. Ibrahim, was your question answered?
Yeah, yeah.
Okay. 10.8.
Yeah.
All right. And this one.
Yeah.
So in rectangular form, this would be, see, the I hat direction, I have 10.8 newtons I hat plus 8.1 newtons j hat plus negative 30 newtons j hat. And we end up with the final force being 10.8 newtons I hat minus 21.9 newtons j hat. Yes, Valeria.
What happened to the cosine and the sine?
What happened to the cosine and sine? The cosine of that angle was 0.8.
Oh, sorry.
Okay.
Where did the negative 30 come from, that answer?
We established earlier that we know that the force coming from here is downwards. And I said that up was j hat. The magnitude of the force coming from 4 we had is 30 newtons. This was the absolute value. And I know it's in the negative j hat direction, so that's where that comes from. This is the force coming, that's this right here.
Well,
Other questions? multiplication, yeah, I can handle that. Did some trig, yeah, I'm good with that. But where's the calculus? How could we be in a calculus-based course and not have done any calculus yet? Well, you're in luck, we're about to. Because this formula here works great if I have 2 point charges, or if I can make an assumption that I have 2 point charges. But suppose I'm not dealing with point charges. Let's deal with a non-point charge problem, where I have a distribution of charge. Make sure I draw my picture correctly. All right, so what I'm going to do is I have a sphere of charge. Just say a hollow sphere. With charge. All the charge is on the shell. Thin shell sphere for those who would prefer that. I'm going to set up a coordinate system here. Just to like stay in sync with my notes. So X, Y, and Z. I have some point here on the surface that is, it's on, so that is, we'll call it point P. P is on the surface of the sphere. The sphere is the radius r, so it's r away from the center. Let's take a point here. I've got multiple colors that I'm using. So that right there is, I labeled that as little r, and the distance from here to here, I believe I used L, yep. I have some charge here, we'll just call this Q. And the charge on the sphere, we'll call it Q sub S. That's the total charge. And what I want to know is what is the net force acting on charge Q here at this point, and the coordinate system would be 0, L, 0. How many of you know the answer already? Okay. Was that almost? Well, this point right here, point P, I have this charge QS around the whole thing, so this point P is infinitesimally small, so I have an infinitesimally small charge right here. So the charge at this point would be some infinitesimal part of Q, so S. And I could, the first time I did this, back in class here, spring of 2012, I get into this triple integral, go through all of it, and look out at and no one's asked questions at this point, I get to the end. And that's when I found out they hadn't done triple integrals before. So, I don't do it that way anymore. But we need to somehow not do a triple integral here, we need to somehow get it in terms of a single variable. So what I'm going to do is, I know that there is a ring of charge here. There's a ring of charge that is the same distance r away from this point right here. And from point P, the force is in that direction. From here, it's in that direction. From here, it's in that direction. From back here, it's in that direction. In other words, I have this cone of forces acting on this point up here. And that cone of forces, well, all the components will be canceled out except for the ones in the one positive y direction. Or I had, J hat, and then K hat coming out at us. So what I'm gonna do is figure out what is the force acting from here, from this ring of charge. I know that it is the same distance R from here, that's the distance L, and there's a lot of symmetry going on there. What I really need to do is just look at the vertical component. Because all of the horizontal components will cancel out. And if you wish, you go through that math and we'll end up with 0 at the end. And there's something satisfying about that, something satisfying about going through a lot of complication, coming out with a very simple answer. But some students have found it, wow, we spent a lot of time on 0. All right, so I need to define, let's go ahead and just call that angle theta, and call this angle up here alpha. Make sure, again, sticking to the convention I have written down. I know that I have this infinitesimal charge right here going around this loop, and so the force on Q is going to be equal, well, it's differential, it's going to be equal to my constant, Coulomb's constant, times the charge at this point up here, times dQs over R squared, times the cosine of alpha. Yeah.
Oh, well, that's just fabulous.
And the rest is obvious.
Well, of course.
Well, let's see what our unknowns are. R is a variable. That's a variable because that's my differential there. Alpha is a variable. I got 3 variables here. Thus, the beauty of the triple integral. However, we're going to get it down to a single variable. Let's start out with, what did I start out with? Oh, first, let's figure out what dQs is. I did not state this, I thought it intensely, and that's fine if you could read my mind, are not uniform distribution. In other words, QS is spread evenly around the entire sphere. So my charge density is equal to charge over area. Since I'm looking at a differential there, that should, if it's uniform, that's true, and it's also true that it's going to be equal to dq dA. That should be a subscript S there. So therefore, dqs is just equal to sigma dA. Doesn't really help us quite yet, but get there. What's the surface area of the sphere? Area won't be cubed. Cube is the volume.
2 pi r.
Circumference of a circle.
Wow.
You were very close.
4 pi r squared.
Yeah. What's the volume of the sphere?
4 pi r cubed.
4/3.
4/3.
Yeah. Volume of a sphere, 4/3 pi r cubed. If you take the derivative with respect to r, you get 4 pi r squared. Same works for a circle. This is for a sphere. For a circle, my area is pi r squared, and the circumference, the derivative with respect to r, 2 pi. All right, so my area is that. So if I take the derivative of the area with respect to r, so dA dr would be so dA is 8 pi r r. I feel like I've
lost something there, let's see. Oh.
That was the one person. Yeah, let's, ignore that. I'm trying to find out what is the area, what this differential area is of this band that is all the same distance from Q right there. So if I look at my sphere, and I'm looking at a band along here, I know that the area of this sphere, well, if I think about it as I've got this band, and basically if I took that band off, snipped it, I'd have just a really long rectangle. Really long rectangle. The area, the thickness of it, it's got to be the thickness here. Well, if my angle theta is defined as that, then this angle right here would just be d theta. And so my arc length, in other words, the thickness of this band would be r d theta. The length here is the circumference of this circle right here, 2 pi times r, and I have to use a different r in there. This right here would be another r.